Hello everyone, in our previous video we have seen the SFD and BMD diagram for cantilever beam for the various load condition like point load, UDL and UVL, and in this video we will see the same all these three cases for the simply supported beam. Okay, so let us consider this to be a simply supported beam. So here it is the simply supported beam and we are applying a point load over it. So this will be the shear force diagram and this is the BMD diagram. So the thing is that how we can draw this diagram and this diagram, that you must understand. Okay, at first we will study about the sign convention and then we will just look into how these figures are drawn. First, sign convention. So according to the sign convention, in which I have taught you in the previous video, if you want then you can just go over there and look. So as per the sign convention, which says that if we want to find out the shear force at this cross section, so let us suppose that this is a cross section XX. Okay, so if a downward, so if a upward force, this is the upward force which is acting in the upward direction, so if the upward force is acting on the right hand side of this cross section, then in that case the shear force will be negative. And if here we have shear force positive, so what it says that if the shear force acting in the left hand side of this cross section is in the upward direction, then the shear force will be positive. So these are the two sign convention that we have seen in our previous video and we have used the same here, and according to the sign convention this will be positive and this will be negative. Okay, now next thing is that how we can just find out these two values, W by 2 and W by 2. So let us suppose that this load W is acting at the center of this beam at a distance of L by 2. Okay, so if you want to find out these two values of the support reaction, then you have to take the moment at any end support to be 0. Let us suppose that I have supposed the moment at this point is 0. Okay, so then what you have to do, you have to do like that this, because of this force it will create a hogging, therefore the moment will be positive. So what you are going to do, you are going to do RB into L minus W times of L by 2 equals to 0, and from there you can get RB equals to W by 2, and when you are going to put W plus when you are going to put RA plus RB equals to W, and we are going to put RB equals to W by 2, similarly you can get the value of RA equals to W by 2. So in this case you have obtained these two end reaction value. Now we have to draw this shear force diagram. Okay, so in the first case this is the force that is being applied, and in this area no other force is applied, so this force will be a constant and we will come at this point, and at this point W load is being applied, so W by 2 plus of W minus W by 2 plus of W will be equals to W by 2 over here, and since no load is applied over here, so it will be W by 2 over here. Next thing is about the bending moment diagram. So bending moment is load into the distance, load is W by 2, distance is L by 2, multiply, you will get WL by 4. Okay, and according to the sign convention, what it says that if it is a sagging, the bending moment will be positive. So if you are applying this force in the downward direction, it will show concavity, due to which the bending moment will be पॉजिटिव, इसलिए ये हमारा बेंडिंग मोमेंट यहाँ पर पॉजिटिव है, बट ड्यू टू दिस लोड इट विल बी अ कनकेविटी, दैट्स वाई इट्स बेंडिंग मोमेंट हैज़ बीन रिड्यूस्ड. ठीक है, so these are the SFD and BMD diagram of the simply supported beam when the point load is acting exactly at the center of it. ठीक है, now the next case is that when this point load is being applied at a certain distance A from the support A and it is at a distance of B from the support B, it means that this load is not acting at the center. In that case again we have to find the SFD and BMD diagram. Okay, so the first thing that you are going to do here is to find the reaction RA and RB. Again you will use the same formula. You have to take the moment at this point to be equals to 0. What you are going to do, you are going to do RA times of L, that is plus RA times of L minus W times of this A, and from there you can get the value of RA equals to WA over L and RB equals to sorry, RB equals to WA over L and RA equals to W times B over L. And the simple process to remember this formula is simply what you have to do. You have to do write W times of this distance divided by L in this case, and in this case of RB you have to write W times of this A over L. So this is a simple way of remembering, and the sign convention is same as I explained before. And same is the case for the bending moment diagram. This is the load W times of A over L divided by the distance, that is WAB over L, and this will be the bending moment diagram. So this is the case, and depending upon the magnitude of values given, we will just go and see one numerical, and then you can understand easily. Okay, so let us consider this is a simply supported beam which is having two loads acting over it. So the first thing that you have to do SFD and BMD. So for that you need to have the end reaction. So in order to have the end reaction, what you are going to do at this point, you take the moment equals to 0. Okay, so this will cause the sagging, therefore this will cause a positive bending moment, and this will cause convexivity, that's why this will cause hogging, means negative bending moment. Okay, so take the moment around this point equals to 0, hence 5 times of 6 minus 6 times of 4 minus 3 times of 2 equals to 0, and from there this unknown quantity RB equals to 5, and this quantity will be equals to 4. Okay, now you are going to just draw the shear force diagram, as simple as that. Take the value of 5, draw a straight line, and this is the value of 6, then you have to draw a straight line over here, and 6 means the value of 1 will go over here. Again, no load means a straight line, then 3, then add 3, and then a straight line, and that will be 4. And again, if you want to draw a bending moment diagram, what you have to do, you have to simply multiply this 5 by this distance, and this distance is how much, 2, and if 5 times 2 is 10, and similarly you can have these diagrams. And again, at this point the moment will be due to this, that is 5 times of this distance, and due to this the moment here will be 6 times of 2. Make sure to use the positive and negative sign carefully. Due to this it will be a sagging, therefore it will be positive, and due to this it will be negative, and therefore when you're going to add both of them, you will going to get the value 8. Okay, so this by this way you can solve the numerical. Okay, now we will just move forward to the next case, that when we are going to apply the UDL. Okay, so as you can see here, this is the case of the UDL. When UDL is applied over this simply supported, okay, again we will do the same thing that we have done in the cantilever case, that the sign conventions are again same, plus and minus, as I have explained in the previous video, that if I'm going to take a cross section over here, and according to sign convention, if the force is being applied in the upward direction, then the shear force will be negative, and if to the left of this cross section, if the force is being applied in the upward direction, the shear force will be positive. So according to that we have plus and minus sign. Okay, next thing is that how this negative has come. Before that you must calculate RA and RB value, since W rate of load is being applied. So converting to the point load, we will be having W times of L, dividing in both of them we will have WL by 2 and WL by 2. So we have got the load, and similarly, and these are the two maximum end shear forces that we have. And if we want to just calculate the shear force at any of these points, so just we are going to just going to find the shear force. If you want to find shear force, let us suppose at this point. Okay, so shear force at this section, let us suppose I want to find the shear force at this section. Okay, just wait a second. If we want to find out the shear force at this section, okay, so we know the shear force at this section is WL by 2, and there it is plus WL by 2. So there will be definitely one value over here. So what will be that value? So due to this we are going to have a negative shear value at this point, that will be minus WL over 2, and due to this UDL there going to be a positive shear force, it means positive. So how much value is going to come over here? That is equals to W times of X. and since the rate of loading is W, okay, so if we multiply W with, let's say suppose this is the cross and this is the distance x, so multiply W times of x, okay, so that will be the shear force at that point. Hence what you are going to do, minus W L over 2 plus Wx, and if you just put the value of x, any value of x over here, then you can get the value of this shear force at this point. Okay, so by this way you just can calculate the shear force any uh, at any section of the given beam. Okay, similarly you just can calculate the bending moment or diagram also. You just need to do this force times of the whatever the perpendicular distance is there. Okay, so if you just calculate this bending moment at any section, then the bending moment will be due to the two forces. First force is this force, and the second force is the UDL. Okay, so the if I suppose any cross section, let's say suppose I want to find out the bending moment at this section, what is the bending moment at this point. So the bending moment at this point will be RB times of this distance. Okay, let us suppose this distance is x, then it will be RB times of x, and due to this force it will cause the concavity or sagging, due to which the moment will be positive. Hence we are going to have RB times of this x, that is positive, and due to this load we are going to have concavity or hogging, due to which we are having the negative moment, and its value will be how much. So we are just going to convert this UDL into the point load. Okay, and if W is the unit load, then that will be Wx, and that will be applied at a distance of x by 2, hence Wx square over 2. Hence at this point the moment will be equals to RB times of the x minus Wx square over 2. And if you use this formula, then you can get the bending moment at any point on the this beam. Okay, so by this way we are going to find out the bending moment and shear force diagram for the UDL load over acting over the beam. Similarly we can just go and solve this numerical solve based on the same thing. If the UDL is given and the loads are being given, if we need to find out the SFD and BMD diagram as we have find out here, we can just find out the values the same way as I have taught before. The only thing that to be noted in this case is that at this section the shear force is 0, and we don't know the what is that distance at which that shear force is 0. So what we are going to do, we are going to use this equation which is shown over here. Okay, we know that shear force equals to 0, so what we are going to do, that the force of 40 is being applied over here, and minus times of 10 times of x, and at this point the shear force will be equals to 0. Okay, so by this way we can just calculate the shear force at this section. Next thing is regarding the UVL. Again, if we are going to apply the UVL at this simply supported beam, and again we have seen here in the case of the cantilever how we are just going to convert this UVL into the point load by just calculating the area. Okay, so we are just going to do half times of base into height. We know the what is the base, we just need to calculate the height. So if we calculate, similarly we can just use all those formula, and then we can calculate the bending force and shear force over here. Okay, so the same thing we have to use over here. We have to just convert this area into a point load, take the CG, and then calculate these values, and convention will be based on what I have just taught. Okay, so by this way we are going to just wind up this session for the SFD and BMD for the simply supported beam, and in the next video we will see the SFD and BMD of different type of beam. Okay, thank you.